Welcome back to our software engineering and project management class. So last time we discussed about process models. We talked on four different types of process flows: linear, iterative, evolutionary, and parallel. Now let us see about some models. Earlier we mentioned that there are two process models that are present in the software engineering. One is prescriptive process models and second is agile process models. So today we're going to discuss about prescriptive process models. Now let us see what it is. So these models they are proposed to bring order to the chaos of software engineering development. So if you remember, we mentioned earlier that there are various people, there are a number of people involved in the project. There are various roles present in the project. So different people of different coming from different backgrounds, they all have different human traits. Then there are different roles which are demanded from the people. It may happen that a same person may have to deal with two or three roles and he may be working on multiple projects. So in such cases, it creates something called as chaos or chaos. So we say that the person may always be on the edge of chaos. So in this kind of a situations, what he may have to face is that there is some kind of order expected and at the same time there is chaos. Okay? So these process models are developed or they are proposed so that we can bring some kind of a structuredness in the development of software projects. So we say that they provide a reasonably effective roadmap. So prescriptive process models so proposed to bring order brought it has been observed that over a period of time they have brought some kind of a structure in the development of software projects and then provide a reasonably effective roadmap for development of software projects. Now when we are saying that yes, it has brought some kind of a structure as well as order, at the same time because of these various kinds of roles and different kinds of people, we say that software engineering work and the product that it produces remains on the edge of chaos. Now what is this age of chaos? This age of chaos, as it is being defined, it says that so it's an age, that means there is some kind of order and there is some kind of a chaos, and person is always try to balance himself in this chaos and try to bring or come towards the order. So it's a natural state between order and chaos. So as we say, it can be two sides of a same coin, but we are on the edge. Okay? So it's a compromise also, maybe between the chaos and the order. We want order. However, because of various kinds of things that are present, it may bring a chaos. Okay? So there is always a tussle between order and chaos, order and chaos. So this age is generally seen as an unstable structure. It has some kind of instability. So it has some part in a chaos, some part in order. So it's unstable because sometimes we may see that it is attracted towards the chaos and sometimes it tries to come or it tries to follow an absolute order. That's why that this tendency, this we can always see that humans also when they are working, they work very orderly, and sometimes we see that there is a complete chaos when a person is working, same person. Sometimes we see there is orderliness in his activities and sometimes we see that there is no orderliness in his activities. So in such cases, this age of chaos theory proposes that we can create some kind of equilibrium. Okay? So because orderliness, there is another theory also which says that if there is orderliness always, it may not lead, this orderliness may not lead to a kind of research. So if somebody wants to do research, we say that we should provide him a free environment. So what basis of this is, if we are providing him a chaotic environment, it may lead to self organization, it may lead to some kind of innovation, it may lead to some kind of a creativity. So both things are required. we do require orderliness. At the same time, we do require some kind of a chaos, because chaos is also important, because this is what they have mentioned that or this has been observed over a period of a time, that research has shown that chaos leads to creativity, self-organization, some kind of equilibrium will be identified if we have some kind of a chaos. So there's a always age of chaos is there, and this will be present. Okay. So these process models, they prescribe a set of process elements, which already have seen lot of things we have seen. It has framework activities, it has software engineering actions, and it has tasks. So same things, activities, actions, and tasks. Same thing that we have seen as a process. Software process consists of activities, actions, and tasks. And then work products, quality assurance, change control mechanisms for each project. So these are defined with this process models. Okay. Work products, obviously we say they are the products, or they are the produce of an action, and every task is supposed to give some kind of a product, work product. Okay. Now obviously for this framework activities, what we said is what lies behind is umbrella activities, which will make sure that there is a tracking, there is a control, there is a quality assurance. So all these things are in place when these framework activities are being performed. So this is what is prescribed by process models. Now, each process model also prescribes a process flow. So this also we can say why it is called as prescriptive. Prescriptive because two things: it prescribes a set of process elements, and it prescribes a process workflow. We have already seen process workflows. We have seen four that we have mentioned, and we'll see that this subsequent point that is mentioned talks about various process models, which will be showing us some kind of a process flow. So we have seen four process flows: iterative, evolutionary, parallel, and linear. Okay. So these are the four various process. These are the process models. Five, 1, 2, 3, 4, and 5 process models are there, which we are going to discuss in coming classes on today also. So the first is waterfall model, then incremental model we'll see, then evolutionary process model, unified process model, and concurrent models. These are various models that we are going to discuss in our classes. Okay. Now let us see the first model, waterfall model. Now, before delving into waterfall model, we are presenting some situations. So, what are these situations? So, these situations are presenting us some kind of information that yes, uh, to choose some kind of process model. So, these are the specifically conditions which are telling us that these conditions or these situations are the ones in which waterfall model will fit. So first is workflows from communication through deployment in a reasonably linear manner. So like the name suggests, it's a waterfall. So waterfall, we know that in nature water falls from top to bottom and it never goes up. That means once some activity is over, that activity is over. We are moving to the next framework activity. Next framework activity. Complete that, go to next activity. There is no coming back, like the water in the waterfall will never come back and again start flowing from the top. No. So that's a waterfall model. It's continuous, it's linear fashion. So first is, there are certain projects in which, or there are certain projects software developments are there in which we can just start from communication, finish the activity, freeze it, we can directly move to the next. So it may be the case that there are some projects which are smaller in size, or projects on which the team has already worked on, so they know that yes, this is what we have done and this is what is required, so they can just keep on freezing the previous activities and move on to the next activity. So there is a flow, there is a linearity is there, like we have seen the linear process flow. The second is well-defined adaptations or enhancements to an existing system must be made. That means you know the system, you know what is to be done, what changes are to be performed, how these changes are going to affect my remaining parts of the project. So because this is known, this well-defined adaptations are there, so there is order. So because of this orderliness, we can definitely follow a linear process model. And next is new development efforts with well-defined and reasonably stable requirements. Remember, these are new development efforts. Generally, whenever we say we are having something coming as a new, it may create a chaos, and it may not have what we say linearity may not be followed, because you may have some requirements initially identified, and then you have to refine the requirements. However, what we are saying here is we have reasonably stable requirements. That means in the communication phase itself, you talked with the all stakeholders and taken from them all the requirements that are necessary. You have freeze the requirements. You have confirmed that yes, no requirements are going to change in future. If that is the case, I am done. I have stable requirements. These requirements are not going to change in future. With that thing, then I can freeze the communication phase, then directly go for the planning phase and modeling and implementation and deployment. That can be performed. Okay. So these are certain situations in which waterfall model fits very nicely, and this is how it looks like. It's a linear fashion. It will move in linear fashion. So in the project, in the communication phase, we initiate the project, we collect all the requirements, we freeze the requirements, we talk. So there may be multiple, you may be doing the iterations here itself. Okay, iterations of communication. Yeah. Talk with the customer first time, take the requirements, note down the requirements, and then create a document, give it back to the stakeholder, ask him, are these requirements correct? He says no, some changes are required, change the document. But in this communication phase itself, you are collecting all requirements, refining the document, creating a document, and freezing it. So you identified all the functional requirements, all non-functional requirements are identified in communication phase itself. Once that is done, then you move to the planning phase, where you estimate how much time is going to complete the project, how much cost is required, how many human resources are required, how many machines will be required, what kind of software will be required, what kind of hardware will be required, will be done in the planning estimation phase. You schedule accordingly then. There will be some activities which can be done in parallel, some which cannot be done in parallel. Do those things and then tracking. Okay, so framework activities as well as umbrella activities. Track your plan, track your estimates, track your cost. Then model, you analyze the requirements, create the model, analyze your design, create it in such a way that this can be converted into a code or construction phase. So once the model is done, you freeze it. You are not going back from model filling phase to the planning phase. From modeling phase only ahead, that is construction phase. You construct, you write a code, you do testing there. So coding testing will be performed here. If there is something wrong in the code, that will see in the testing, correct it. Then again modify the code, again test it. If there are some certain changes to be performed, again correct the code. So this will be happening in the construction phase. Again, we are not going back from construction to modeling. We'll move only from construction to develop deployment phase. So that's why we are saying we are moving only in right hand direction. So from left hand, from communication to deployment. So movement is, or the flow is a linear flow, a sequential and a single direction. Okay. And then we have deployment, where we deliver the product and provide for maintenance and support activities, take feedback and do the remaining things. So this waterfall model, it generally is being given by this Winston Royce around in 1970. This model was given. This model is still being used at a lot of places, and sometimes we may not be using it. Subsequently, it has been modified to call it as a V model also. So this waterfall model is a classic life cycle model. We call it as a classic life cycle model, and obviously it is systematic, because what we say is in every phase, like communication, then planning, modeling, design, modeling, construction, and deployment. Every phase will be systematically completed then and there itself. We are not moving into the subsequent phase without completing the previous phase. So it's a systematic sequential approach for software development, and this begins, like we mentioned, with customer specification. Then we do planning, modeling, construction, deployment, and obviously what we continue is we continue to support the project or the deployed product. So subsequently, a variation in presentation of this model is presented as is called as V model. Okay. So in the V model, if you see, what we are presenting is you're balancing these things. Okay. So in the V model, you are doing it has two activities: earlier engineering actions on left hand side, and verification and validation also is done parallelly. That's why you call it as a V model. So what it does, if you see, V models depict the relationship of quality assurance actions to other activities. So on right hand side, what you see is a quality assurance activities or actions, and these are mapped to the actions. Right? The actions are engineering actions like requirement modeling, design, component design, code generations. There are various phases, and for these phases, for these actions, we are providing the quality assurance activities simultaneously. So if you see here, we are moving from the left from requirement modeling towards code generation. So what happens here is we are trying to refine all the requirements or all the functionalities from requirement gathering towards code generation. So we keep on or we make it sure that all these requirements are taken properly, are modified, are refined, and we are moving downwards towards more and more details. Okay. Once that is done, then we start doing unit testing. So what happens, if you see here, when your code generation is ready, what you have is the entire code. There you can see each and every function. So those blocks are available with us. So we go for unit testing. Okay, so we can test the individual functions which are defined again in the requirements. When we did the component design, okay, so this designing part is split into two parts here. We say architectural design and component design. Okay, so architectural design more or less tells you about the deployment parts, or how the system will be placed in some kind of an environment. So architectural design is for that purpose. We'll see subsequently that also in the next unit. So here unit testing is performed for the functions. When we have components present, so when we have merged two, three, four functions together and created a say module, so that component is there, so that module will be tested with integration testing. And then this also integration testing also will help you for architectural design, because when this component is placed in some kind of architecture, how it's going to function. Because what though we are following the V model or waterfall model, we are having some details available at every place, and we do have modeling, we do have modulation done. So we have identified individual functions. When these functions are merged together, we're going to form a component, and multiple components will be again integrated together, interface together to form the entire system or a product. Okay. So in that case, we'll do integration testing for component design as well as architectural design. The system testing will be performed. This may be part of your black box testing, where you don't see the code now. You don't see the code. What you have is the entire system available. You give the inputs, you see the outputs. So in that environment, you are going to test all your requirements, because requirements you have already gathered and you did the code generation also. Now we are moving up and we are performing the system testing for architectural design also and requirement modeling also. So whatever requirements are there which have been modeled, which have been identified for all those functions, whether they are functional requirements or non-functional requirements, for which we perform system testing. So we are verifying whether my requirements are being satisfied by this product or not. Once that is done, we look for acceptance testing. We may give it to customer, or we may ourselves test it for different purposes, whether this is acceptable product. Can we compare this with some other products also, compare its performance with some other products too. So that is being performed for acceptance testing. That's a V model. So its shape is like V. Okay. So on left hand side, as we move downwards, we have more and more details, and as we move upwards on the right hand side, we start from the small say functions, but we start from small verification of small units or functions, and we move towards the verification and validation of the entire product. Okay. So that's how we this model is being developed. Okay. Now this model, if you see what it talks of, whether it's a waterfall or this model, this is available since long time. We mentioned it's the 1970s. Okay. So almost it's 50 years that this model is in use. Okay. They are being used. However, they are questioned for efficacy. This oldest paradigm still being used. Many people still use it. Obviously, you may also be you have used it unconsciously, but you have used it. Okay. So This is the oldest paradigm, but it's question for efficacy, whether it's efficient or not. Because every problem is not sequential. So there are problems which are present because the world has changed. We are not building a products which are closed door products. Our requirements may keep on changing because the market conditions may keep on changing. Customers may keep on asking for certain changes because on his side the requirements may change. We have seen certain meets, right? We have seen customer meets, we have seen management meets, we have seen different meets for in these cases. So they do affect the development of a product or project. Okay? So real projects rarely follow the sequential flow. We cannot say that once the communication phase is over, we will not talk with the customer till the time our coding is not done, or directly we'll give the products to the customer. No, we have to keep on talking with the customers. So there has to be iterations. Okay? Communication phase, in the first phase or in the communication phase itself, it may not be the case that you're going to get all the requirements to with all its details. It may not. It's not possible. So in such cases, this may happen because many times the customers don't know. We have seen the customers many times don't know what they want. Okay? They may say superficially, I want this kind of a product, but how actually it's going to work. That's why if you have seen, we have mentioned in the patterns, like when you have a pattern, so we mentioned a pattern requirements unclear. So there we mentioned that the user don't know what kind of requirements he is having. He know that he in his brain he has some kind of a product, he has some kind of idea which he wants to get converted into a software, but he doesn't know all the requirements. In such cases, what the team does is, we mentioned that they create a prototype kind of product, give it to the customer and say whether you want this kind of product or not. If he says yes, you go for the further requirements. So in that case, if you see the prototype, what we have done is we have collected the requirements, we did the design, we did the modeling, we planned, we coded, we tested, gave it to customer. So this is, but that's not the entire product, because we mentioned that this prototype may be thrown out. It may not be considered subsequently. So real projects will rarely follow the sequential flow. Second is, it is often difficult for customer to state all requirements explicitly. We just explained that. And a working version of the program or programs will not be available until late in the project time span. That's the problem of waterfall model, or whether it's for or V model, because what we mentioned is, you take the requirements, model the requirements. Now working product means you are going to deliver the entire product. The customer will not be able to see or will not be able to know what is happening with my product or with my program. What will be given to him is the working version, and that will be late. If product span is of say 6 months or 1 year, at the end of 1 year you are going to give him the product. Okay? So that the customer may not like, because you may just be informing him, okay, we have reached this milestone, we have reached this milestone, we completed the design, we completed the planning, we have completed modeling, we are about to finish coding, we are about to finish testing. But the customer may not be interested in those things. He may like to see, okay, show me how my product is looking now, you show me what kind of functionalities are available right now. But that's not being given in this waterfall model. What it says is, once you finish the testing, after testing only, you give the product to the customer with all the requirements that he has defined. Now if something goes wrong here, then it's a big loss for both the parties. Okay? So that those are some of the problems that are encountered in this waterfall model. So linear nature of the classic life cycle leads to blocking states. That's what I mentioned. We first block, we complete the communication activities, we block communication activities. We are not coming back to communication activities once it is freezed. So there is a term called as freeze. We freeze the requirements, then we freeze the plan, we freeze the model, we freeze the code, and then we, once the deployment is there, it's a product. Just give it to customer, nothing will be changed in that case. That's difficult for both the sides. If subsequent support, if subsequent changes are required, it will be difficult because you already blocked the previous stages or states or phases.